Hello, welcome back to Blender Sushi Live Noding. So in this video, I'm going to continue with the study of this Entagma knitting problem. I watched the video a little bit more, and then I found this procedure that they use to kind of look at the UV, like a flat UV, and kind of project it back into the 3D space. It's very interesting. It's not like something that someone can just, okay, let's just do it. You need to kind of think about it. The part that I really like is actually when they lay out these circles in a grid fashion, and then they kind of draw this kind of like the element of knitting pattern. This one, I think I can simulate it in Blender using Squarechalk. Yeah, let's just do this first. Just like make like a flat knitting pattern. Let's start with a circle. Okay, I'll just start from scratch. So this is Squarechalk add-on. Create a node 3, and I'll create a circle. I'm gonna draw it, and this circle will be just like kind of like a guide. So I will just turn it into edges and make it like a wireframe. And go to the top view, and I'll use a grid matrix for this. Plane, plug this into the matrix, and I know the fact that we can simply kind of lay it out in a way that looks like something like this. So should be more or less, this could be like our starting point. So that should be pretty good. Actually, should be, this one should be touching and overlapping a little bit in the X. So this is kind of the basic I want to start with. Yeah, something like this, and we start to get the knitting pattern. What I will use here is grease pencil to kind of quickly draw the shape. So hopefully this works for us. This one, I kind of imagine if this guy start from here, and so if I draw it using grease pencil, roughly the knitting pattern should go like this, and then kind of going up and then back, and like that. So that's kind of the idea. So that the first one looks pretty bad, so I'm gonna try again. Delete this. Just gonna draw it. Well, this part can be a little bit better. I'm just gonna probably use this proportional editing. Okay, so certainly that can be better, but that's a good starting point, I guess. So we have, we don't need to use this circle anymore. This is like a template. I think we can actually procedurally design the whole pattern, and we don't need to draw using grease pencil. But that's gonna be a little bit harder. Using grease pencil, it's a good start. So this is a start circle template, and the next step is to create another node 3 and then use a grease pencil. Let's just this setup right here. Grease pencil and make it like a GP layer. Pick a frame. And let's update this. So we have this guy right here. Let's check how many points we have. Length, this length, get the points. Stethoscope, we have 27 points, so I'll make it smaller. So 26 looks like a good number. Okay, 26 can be 24, but yeah, something like that. 24, actually 25 is actually better. Okay, now 25 points, resampling this grease pencil. And so we can now kind of repeat this pattern. I'm gonna hide this. So we have the grease pencil, we can use it up here. So that's viewer draw, and I will use apply, matrix apply, and this guy goes in there. The matrix goes in, and we're gonna use a grid pattern, and we're gonna kind of eyeball it. Hopefully this actually works. Kind of like doing improvisation here. So yeah, the idea is really to make the knitting sort of work like that. Just make it like kind of touching. Actually, this can be a little bit better. Well, anyhow, should be okay. And gonna adjust this. I think should be like that. So that's our knitting pattern. If it's laid out as a grid, let's make it like 6 by 6 and then turn off the points. Now from this flat knitting, we already have like a starting point. You can definitely bake this, you know, this become like a single element. And if you are using like a cube, so you have this cube, and maybe you smooth it one time, and you use this guy, select this guy, and use a sphere chalk adaptive polygon, or in this case I'm just gonna use a tissue tessellate. This should actually work as well. So this is the component. So select this guy and select this guy, tessellate, use modifier, just hit apply. Oh, actually this one need a face. Okay, I just gonna turn on skin modifier. So that takes care of this. So that's kind of where we are going with this. So set origin to geometry. So we have this. So select this and select this guy. Apply, scale, apply. Select this and select this, and then tessellate and hit OK. Hopefully this guy will generate. See, that's kind of the knitting pattern that we're gonna try to recreate. But with the Houdini one, Entagma Houdini one, they did something really clever. So they look at the UV and then kind of look at the UV on the actual 3D surface, and by doing that, they actually make this guy very smooth, kind of like a ball. This one is flat, right? So, but anyway, before we go too far, this thing is still flat, so I think we can do a little bit better. And I suppose we can, let's say this is the matrix for the templates duplications, but here I'm interested with this guy right here. So we draw it using grease pencil, and it is totally flat. But if you use like a move, and this plug in there, this goes in there, and this, we have 25 points, so we can maybe use math sine wave here, and this guy can goes in there. Slightly tricky. It's not actually that complicated, so we're gonna kind of make it ups and downs in a sine wave kind of pattern, and we need a range of number between 0 and 25. Something like this. So this guy goes in there. So I believe this, we are no longer get like a flat surface, but it's more like a sine wave. Well, actually we can do it this way. That's the idea there. So the knitting pattern should go like in and out. The nice thing, of course, this is pretty much procedural. So sine wave, and this is the number between 0 and 25. This goes in there. And map range can take care of this, I believe. So old mean and max 0 and 25, and new mean and max is for the sine wave. So we really kind of make like a wave here. Well, I'm gonna turn on the point so we can see clearly what's going on. Sine wave, this guy really should be like a pi. So math multiply pi times x. Okay, this maybe this is the one we need. Integer. So this is 1 pi, 2 pi, 3, 4, 5, 6. So we can see it's kind of going up and then down, kind of interlocking with each other. I think 6 is good value, or maybe 8. I don't know. I think 6 is good. 6 pi, and we can tell if we are doing this correctly if we join it here. We can actually remove double here. Vertices and edges. So we try to connect this guy together, but well, it's end up interlocking with the other guy there. Yeah, tricky, pretty tricky. And let's increase this a little bit higher, the sampling. Higher sampling, that means you're gonna get this thing that's closer together. Let's just adjust it here. Well, I might need to adjust the grease pencil, but anyway, this is like the knitting starting to happen. Ideally, this remove double should merge the knitting, kind of like that. Oops. There you go. I think it's kind of connected. Okay, so that should be good. And then the next thing we want to do is skin modifier up here, and just plug this guy like that, turn on live, and we have our knitting. Probably it's not perfect, you might need to make adjustment, but this is the idea anyway. And then you can always smooth it. They should be connected together. Maybe it's not totally perfect here, maybe increase it slightly. Yeah, now my MacBook is kind of frozen. Terminate and restart. So again, I'm using Mac OS High Sierra, and yeah, my graphic card is pretty bad. It's pretty old, so it's tend to crash Blender. But if you are using a like modern computer, 1 year old, this should be like a no problem. This should be correct. Too close. There you go. I mean, more or less, this is the idea. The knitting can be better. Yeah, this is like a flat design. And if you want to do like the Entagma thing, you need to kind of adapt this flat knitting into the 3D surface, and then kind of find a way to wrap around it. You can probably use this tissue add-on lattice along surface. I don't know how, but for each like flat pattern, you kind of want to project it into the surface of 3D objects, and that way you can really wrap around the 3D objects just like a real knitting surface. So it's pretty tricky stuff, but you know, the fact that you can do this, everything is procedural, and you can just grab this from me and play around with this, and you can quickly change the knitting pattern here, the elements, because this is a grease pencil and it's still alive, so it's very powerful. And you can always increase the number of the knit pattern. This is only one knitting pattern. There are plenty of ways you can do this knitting. There are actually algorithms that's dealing with this knitting pattern. It's actually quite an interesting subject. It's almost like the origami algorithm one. So yeah, it's tricky stuff. It's not like something you just, oh, it's so easy. And if it's becoming one-click solutions, then someone has spent some time to actually make this. And just like what Entagma was doing, that's like, if you got the file, Houdini files, and you can just use it, it's like pretty amazing. Anyhow, this is very interesting problem, and maybe I'll think about it further if I find the solution. So next time you can just fit this guy into Susan's head. At this point, this is like a single object, and you can really you can use this actually. This is no problem. You can use the tissue add-on, just assign it to Susan's head, for example, and you're gonna get quite a result. Even though it's a little bit blocky, you need to kind of smooth it and make some kind of projections. I'm not sure. Maybe one of these can work. The shrink wrap might work if you're being clever, but you need to ensure that the knitting pattern is not becoming flat. You need to maintain the solidity of it. And once you get the result, you can actually print it out, and it's gonna be looking pretty cool, I guess. I don't have 3D printer here, but if you have, maybe you want to give it a try. So that's pretty much it for this live noding. It's a little bit more complicated, but anyway, Entagma already give like the solutions there. Once again, thanks to their tutorial. Where is it? This is like the kind of thing that I really like. I collect this kind of thing, you know, like this is like the recipe to make a procedural design, and you can simply use this theory and then apply it using something like SquareChalk. Yeah, this is the idea. Anyway, thanks again for tuning in, and let me know if you have any feedbacks, another way to do this better. Thanks again, and I'll see you in the next video. Thank you. Bye.